Okay, now let's tackle these last two cotangent graphs. Before you do any of these graphs, it's good to remember what is the period of a cotangent? It's pi over b. Okay. And what is the pattern of a cotangent graph? Well, it starts at 0 and it's asymptote, high, middle, low, asymptote, unless there's a reflection. So this is a typical cotangent graph. Okay, so that's good to keep in mind. So on your worksheet, I just did this on blank paper. We'll say, what is the value of A? Okay, the value of A is 5. Okay. Is it reflected? Yes, this time it's reflected. Yes. Why? Because of that negative right there. Okay. The period is typically pi over b, but the value of b is pi. So it's going to be pi over pi. So the period's going to be 1. And the spacing will be the period divided by 4. So 1/4. There is a vertical shift. Up 2. There is no phase shift. And we will be labeling the vertical asymptote when we get there. All right, ready? What is the spacing? It's 1/4. So this is y, x. This is 1/4. So I'm going to go 1/4. Plus another 1/4 is 1/2. Plus another 1/4 is 3/4. 1, 5/4, 6/4, 7/4, 8/4 is 2. Okay. It is a vertical shift up 2. So we'll say this is 1 and this is 2. Okay, so I'll go ahead and change that to make that my vertical line. My new vertical line goes right there. Now, this means we're going to go up 5 and down 5 to hit those points. But the fact that it's reflected, normally we go high, middle, low. The pattern will be, because of this, low, middle, high. Where is the middle? The middle is at 2. How high? 5 above. 2 plus 5 is 7. 2 minus 5 is -3. So the low's going to be down here at -1, -2, -3. And the high is going to be up here at 1, 2, 3, 4, 5. This is 7. This is where the high is going to be. Okay. It was no horizontal shift. So that means the vertical asymptote is at 0. Okay. And then we'll go low, middle, high, and then at 1, it's going to be another asymptote. Low, middle, high, another asymptote. If we go backwards, another asymptote. Okay, now, let me make sure. Cotangent is normally high, middle, low, but this negative makes it low, middle, high. We got shifted up 2. So the low, instead of being -5, is -3. So our first move at 1/4 is to go down to -3. And then it's middle. And then it's high. Oh, no, this is not the middle. I always get the wrong line. This is the middle at 2. And then the high is up here at 7. And then asymptote. And then low, -3. And then middle. And then high at 7. If we were to go backwards, the high would be up here. The middle would be here. The low would be down here. And this reflected cotangent graph looks an awful lot like a tangent graph. In fact, it sort of is one. The vertical asymptotes ended up being at x is -1, 0, 1, and 2. All right. What if we did this? What if I said, where should we start and where should we stop this? A normal cotangent graph goes between 0, not or equal to 0 and pi. You could say, oh, normally it's going to go between 0 and pi. Remember what we did with tangent? But we could put this whole thing in there, pi x, and solve for x by dividing everybody by pi. 0 divided by pi is 0. Pi divided by pi is 1. Pi divided by pi is 1. This is where you can start. This is where you can stop. We are going to go high, middle, low, except it's reflected. Asymptote, low, middle, high is what's going to happen in there. All right, so you can do that little thing I did with tangent on every single graph. I think it's most handy to do with tangent. So let's do this. Cotangent of 2x. I am going to do it here again. 0, 2x, pi. This is its normal pattern. What is the value of a? It is a 4. Is there a reflection? No. None. The value of b is 2. So the period is pi divided by b, or pi over 2. The spacing is the period divided by 4. So this is going to be pi over 8. That's the spacing. That's how we mark up our x-axis. So let's do pi over 8, pi over 4, 3 pi over 8, 4 pi over 8. This is pi over 2. 5, 6, 7, 8 pi over 8. This is pi. Negative 1, negative 2, negative 3, negative pi over 2. Negative 5 pi over 8, negative 6 pi over 8, 7 pi over 8, 8 pi over 8, negative pi. All right, that's how we mark up our spacing. Is there a vertical shift? Yep, it's going to be down 3. There's no phase shift. Phase, that's an E, phase shift. Okay. All right, and we got to do the vertical asymptotes. Okay, here we go. I got to solve for x. Tell me where to start. Divide by 2. 0 divided by 2 is 0. 2 divided by 2 is 1. Pi divided by 2 is pi over 2. I'm going to start at 0. I will stop at pi over 2. This is where a vertical asymptote goes. Vertical asymptote goes. Its cotangent is going to be high, middle, low. How high? I got to figure this out. It's being shifted down 3, down 1, 2, negative 3 is my new midline. All right, negative 3. All right, so I'm going to go up 4. 1, 2, 3, up 4. 1 is going to be the highest. I'm going to go down 4. 1, 2, 3, negative 7 is going to be the lowest. This is cotangent. That is not reflected. So the pattern is high, middle, low. So it's going to be asymptote at 0. High is going to be the first spacing over, which is going to be at 1. Middle, low, asymptote, pi over 2. And then it goes high, 1, middle, low, negative 7, and then it goes asymptote. If I'm going backwards, it's going to go, first one will be low, and then it'll be middle, and this will be high, and this will be asymptote. This would be low, middle, high, and this would be asymptote. Okay, where are my vertical asymptotes? At x is negative pi over 2, 0, pi over 2, pi. What does my pattern look like? It looks like a stretched tangent graph. Here we go. What is going to save you when you graph like I do? Labeling. Labeling your x-axis, your y-axis. So I can see that this is -7, and this is a 1, and this is a 0, -1, -2. Your x-axis, this is what's going to let me know that you know what's going on when it doesn't look like your calculator. Okay, that is cotangent. I can find the stop button.